Okay, so we've looked at the divisibility rules, particularly paying attention to prime numbers. And now we're going to use that to write numbers as the product of their prime factors. So you've got prime numbers and you've got other numbers called composite numbers. That's numbers that are made up of prime numbers. And every composite number can be written as the product of its prime factors. I'm going to show you how to do it. Let's start with a fairly large number, and I'll do another example, and we'll see how it's done. So let's look at the number, say, 720. The first thing I need to do is I need to think of a prime number that goes into it, and it's best to start with the smallest prime number that will go into it. Ends in a 0. If it ends in a 0, 2, 4, 6, or 8, then it's an even number. It's divisible by 2. So I'm going to divide that by 2. I'm drawing a little division bar thingy there. I'm doing it upside down, but this still works. So 2 into 720, you could do that by going 2 into 7. That would be 2, 3. You would carry 1 across there because there'd be 1 remainder. And then 2 into 12 is 6. And 2 into 0 is 0. Half of 720 is 360. You might even just know that anyway. You might even think, oh, 720, 72, 36, 360, okay? So now what do? I've got this big number here. That doesn't look like a prime number to me, so I have to continue the process. I can see it also ends with a 0. So I'm just going to keep dividing by prime numbers until we get to the bottom. So 360 divided by 2 is 180. You might realise that 36 divided by 2 is 18, so we've got that going for it there. 180 ends with a 0 as well, so I'll just keep going. 180 divided by 2 is 90. I think of 18 divided by 2 is 9. Then 2 into 90, okay, yep, because it ends with a 0, is 45. Right, so finally it looks like we've got something different here. So with that 45, I can not divide by 2, it ends with a 5, which is an odd number. 45, I could obviously divide it by 5, but I also know that when I think of a smaller prime number would be 3, and I know that 3 goes into 45 because if you think of a clock, you go around 15, 30, 45 minutes. So 3 goes into there 15 times. And because I know my 3 times table, I know that 3 goes into 15 5 times. Now 5 itself is a prime number, so I'm going to have to divide it by the smallest prime number that goes into it, which is 5. So get 5 out here, and we end up with 1. You'll always end up with 1. Okay, that's going to be the last number because we're going to divide it all the way down. So I can get all of these factors here, and I can write it as 2 times 2 times 2 times 2 times 3 times 3 times 5 equals 720. Because at each step I've been dividing by these, so what's the word I'm looking for? The inverse of dividing is multiplying. So that's great. I've just written that as the product of prime factors. There's one more thing I can do, because this whole topic is called indices. I could write this as the product of prime factors in index form. So you notice here I've got 2 times 2 times 2 times 2. How many 2's is that? 4. So that's the same as 2 to the power of 4. How many 3's do I have here? 2 of them. So that's the same as 3 to the power of 2. And with that 5, how many of those do I have? 1. So I could say 5 to the power of 1, which is just 5. And that's equal to 720. Okay? So if you're wondering why we needed to do division rules, this is why. Now, you could do this with big numbers, you can do it with small numbers, you can do it with anything. So let's just try another number. What if I had the number 49? This is going to be a very short one. 49. Can I divide it by 2? No, it's an odd number on the end. Can I divide it by 3? Well, it's got a 9. I know 9 is divisible by 3. But if I do a bit of further investigation, I'd find that actually 3 doesn't go into 49 if I use my calculator. Or if I use the rule, 4 plus 9 is 13, and 13 is not divisible by 3. Let's see, what else? 5. 5's not going to go. 7. Oh, yeah, 7 is 49. So, divide that by 7. I'll be left with 7. The only thing that can go into 7 is 7, and, well, this is 7 times 7 equals 49, or 7 squared equals 49. What else can I do? Let's do another one. What about if I did 102? This is also going to be a short one. 102, let's see, ends with a 2, it's divisible by 2. So I'm going to divide that by 2. And if I divide 102 by 2, I get 51. Now, it's 51. That's not divisible by 2. Is it divisible by 3? 5 plus 1 is 6. 6 is divisible by 3, so this number is divisible by 3. Then I'd have to work out how many times 3 goes into 51. So if you can't do that in your head, you might need to get your calculator out, or you could do it on paper. I happen to know it's 17. 3 times 17 is 51. And 17, you could try dividing all sorts of things into that, but I'm just going to cut to the chase and say, well, that's the prime number. So 17 goes outside here, and I'm left with a 1 down there. So, writing this as product of prime factors is just going to be 2 times 3 times 17 equals 102. And writing that as the product of prime factors with powers on it, or indices on it, really, I've only got one of each of them, so if I really had to do that, I'd just put a 1, a 1, and a 1 to be complete. So I hope that gives you a bit of an idea. It can be really long, and that's okay, don't be stressed out by that. If it's really long, they'll probably give it to you with divisible by 2 to start with. Or it could be really short. You might find that it doesn't go for very long at all. Okay? There is an example in the book, so you can try that. And good luck.